You have to know that there are many types of bunker buster bombs, but one stands out: the GBU-57. And this huge bomb is usually dropped by the B-2 Spirit stealth bomber, the most expensive bomber ever built. It costs $2 billion per unit. And because it's so big and heavy, the B-2 can only carry 2 of them at a time inside its bomb bay. Also, the GBU-57 doesn't have rockets, but it has 4 special fins and a smart GPS system that guides it exactly to the target. It's made from a super strong type of steel. Its heavy weight helps it fall fast and punch deep into the ground, up to 200 feet through soil or concrete. In this video, we'll also show how the GBU-57 compares to other powerful bombs, like the massive ordnance air blast, the mother of all bombs, and how each one works step by step. To understand how powerful bunker busters are, let's look at a few examples. First is the BLU-109, said just blue, a 2,000-pound bomb from the 1970s. It can break through about 6 feet of strong concrete. Next is the GBU-28, which has a laser to guide it to the target. It can dig almost 20 feet into the ground. That's as deep as a 2-story building is tall. But both of these are small compared to the GBU-57, which can go down over 200 feet into the earth. That's about as tall as a 20-story building flipped upside down. These examples show how much bunker buster bombs have improved over time and how deep they can go. Now imagine a regular person standing next to this bomb. It's 20.5 feet long. Its long and smooth shape helps it fly straight and hit its target with great accuracy. It's 31.5 inches wide and weighs a massive 30,000 pounds, or about 14,000 kilograms. This huge weight gives it the power it needs to break deep into the ground. Because it's heavy and compact, it can punch through more than 200 feet of concrete, making it one of the strongest bunker buster bombs ever made. Let's take a closer look at what this bomb is made of. The most important part is the outer shell, made from a strong cobalt steel alloy that can survive hard hits. Interestingly, the outer shell makes up over 80% of the bomb's total weight. Inside this shell, we find several key parts. At the very front is the nose fuse and fuse conduit. These parts help start the explosion. Inside the fuse conduit is the main explosive, a 5,000-pound warhead, around 2,267 kilograms, packed with powerful explosives. At the back, the conduit connects to a tail fuse. This tail fuse is the main part that triggers the delayed explosion after impact. Now to the tail, where we find the bomb's guidance system. Here, an internal navigation system works with a military-grade GPS to guide the bomb directly to the target with high precision. Nearby, there's an adapter ring to attach a telemetry antenna for sending flight data, and a secure battery that protects sensitive information. Going deeper, we see thermal batteries that power everything, and strong fins made from composite materials that help steer the bomb. These fins are controlled by internal gears that move them very precisely, helping the bomb adjust its flight path while falling. Now let's check out a smaller bunker buster bomb and how it works. This one has a laser sensor in the front and adjustable fins right behind it. In the middle, there's a 650-pound warhead filled with tritonal, a mix of 80% TNT and 20% aluminum powder, which gives it extra explosive power. At the back are foldable fins that help guide it to the target. To better understand its size, let's compare it to a person. The bomb is about 19 feet, 5 meters long. Its shell is made from a strong artillery barrel and is 14.5 inches, 37 centimeters wide, narrow for a bomb this powerful. The small width is no mistake. It helps the bomb go deeper by pushing aside less material. Whether it hits dirt or solid concrete, the narrow shape helps it slip deep into bunkers and buildings, avoiding strong steel or thick walls. Let's return to the GBU-57 and how much it costs. Developing this bomb costs between $400 million and $500 million. Each one costs about $3.5 million to make. In comparison, the GBU-28, which weighs 4,000 pounds, costs between $100,000 and $150,000 per unit. The smaller BLU-109 costs even less, between $25,000 and $84,000 per bomb when including the JDAM guidance kit. Let's examine how this system functions. Step 1. The bomb is carried by a B-2 stealth bomber flying at a very high altitude. When the plane reaches the target zone and conditions are right, it drops the bomb. The bomb is made for precision. The height from which it is dropped affects its path and performance. Step 2. Targeting accuracy begins. The bomb uses advanced guidance systems, including GPS and inertial navigation, both based on military satellite data. Step 3. The bomb adjusts its flight path. Guidance data is sent to 4 fins at the back of the bomb, called lattice motor fins. These fins move in real time to steer the bomb as it falls. This is necessary because the bomb does not have engines to change direction. Instead, it relies on these moving fins and the high-altitude drop to guide it. That's why a high-altitude release is critical. It gives the bomb time and space to adjust accurately. Step 4. Impact and penetration, the most complex stage. The bomb, called the Massive Ordnance Penetrator, MOP, weighs about 30,000 pounds, around 14,000 kilograms. On impact, it hits with great force and is designed to go deep into hard structures like bunkers. Its impact energy allows it to dig over 200 feet into reinforced concrete, placing the explosive charge exactly where needed. Step 5. Arming the bomb. It has 2 small-diameter bomb SDB fuses installed. These fuses act as backups for safety and reliability. One fuse reacts to G-forces, the other is a timed delay. This setup was redesigned so the bomb could hit deep underground targets protected by strong materials. The fuses are at the rear of the bomb to reduce the risk of damage. When the time delay or G-sensing fuse activates, the bomb explodes and can create shockwaves strong enough to collapse bunkers and bury large buildings. Many confuse the MOP with the MOAB, or Mother of All Bombs, which stands for Massive Ordnance Air Blast. The MOAB weighs about 21,600 pounds and explodes above ground, producing a large shockwave and blast area. But unlike the MOP, the MOAB does not penetrate underground. The MOP can go as deep as 200 feet underground before detonating. The MOP can be launched from bombers like the B-2 Spirit. But the MOAB is too large for bombers and must be dropped from a C-130 aircraft using a pallet system. After release, the MOAB is slowed by a parachute and guided by inertial navigation and GPS as it falls. On April 13th, the U.S. dropped one of these large, non-nuclear bombs on a tunnel complex in eastern Afghanistan. The explosion removed oxygen from the caves, making them uninhabitable. If you enjoyed this content, please subscribe to Best of Militech, leave a comment, and share. See you in the next video.